Hello students, in this video we'll compute the Fisher information for a Cauchy distribution. So let's suppose x is Cauchy with parameter theta. That means its PDF, f of x and theta, is 1 over pi, 1 over 1 plus x minus theta, quantity squared for x in R. That's what a Cauchy distribution is. And so we're going to compute the information, so the information and the parameter theta. Recall what the information is. It's the expected value of the derivative of the log f of x and theta, quantity squared. Okay. It's also equal to negative the expected value of the second derivative with respect to theta of the log of f of x and theta. Well, this one's actually a little bit easier for this problem, so let's do it like this. So let's compute the log of this thing. So it's the log of f of x and theta. It's going to be negative the log of pi, and then negative the log of 1 plus x minus theta squared, like that. Great. And so now what's the theta derivative of this thing going to be? The theta derivative is going to be of log of f of x and theta. That's going to be 0. I'm going to have a negative 1 over 1 plus x minus theta squared. And then times the derivative of x minus theta is going to be a 2x minus theta times a negative 1, right? So this is going to be what? This is going to be 2x minus theta, all divided by 1 plus x minus theta, quantity squared, like so. Great. All right. And so now what I have to do is I have to square this expression and integrate it, right? So in other words, what is now the information? The information is the expected value of the square of this thing. That's going to be a 4, and then x minus theta squared over 1 plus x minus theta squared. And so now what we'll get is, let's plug in what the PDF is. We know what the PDF is, of course, right? This is going to be the 4, the integral over R, right, of, I'm going to have an x minus theta squared over 1 plus x minus theta squared, times a what? Times a 1 over pi. So let's bring that pi on the outside over here, like that. And then what? And then we'll have a 1 over 1 plus x minus theta squared dx. Okay. Now the first thing I'm going to do is I'm just going to let y be x minus theta and shift everything over. So I'm going to set this, since this is center, that's not going to change the differential or the convergence at all. So if we shift everything over, this is exactly equal to 4 over pi, and then the integral over r of just x squared over 1 plus x squared, quantity what? Quantity cubed. And so now here's our famous trick. One of the things we love to do with the integrals of this form is I'll have to just add and subtract in one to these things, dx of course. And if I do that, I'm going to get the following. I'm going to have a 4 over pi, integral over r. And then if I have x squared plus 1 over x squared plus 1 cubed, that's going to be a 1 over 1 plus x squared. And then I'll have a minus 1 over x squared plus 1 cubed dx. Okay. Now there's a clever trick we can do with inverse tangent to help us figure out what these integrals are over here, right? So in other words, if I look at this, so I notice that if I look at the integral over r of 1 over t plus x squared dx, then this of course would be what? This would be the 1 over root t tangent inverse. This would be 1 over root t tangent inverse of x over root t over r, from negative infinity to infinity. Well, of course, the positive infinity is going to give me a what? It's going to give me a pi over 2. The negative infinity is going to give me a negative pi over 2. So this is just going to be a t to the negative 1/2 times pi. Great. Now, of course, let's do some derivatives of this thing over here. So if I took this expression and called this thing over here phi of t, then what can we say about phi prime of t? What's phi prime of t going to be? Well, this is really, so phi prime of t, for example, phi prime of t. On one hand, it's going to be what? It's going to be negative 1/2 t to the negative 3/2 times pi, right? And then that will also be equal to what? That'll be equal to, if I do the t derivative of this thing, it's going to be this is just really just going to be a factor of what? This is really just xt plus x squared to -1. So the t derivative of this thing is going to be -1, and then integral over r. And then I'm going to have a -1 over t plus x squared dx. Great. And so in particular, that's going to tell me that this integral over here, so those are going to cancel out over there. Those negatives are going to cancel out. So I said, if I plug in t equals 1 to this formula, I have 1 over 1 plus x squared is equal to this expression when t is equal to 1. So that's going to be a pi over 2. So this integral over here is going to be a what? I just figured out that integral is going to be a 4 over pi. And then this integral over here, as we see from our formula, from this phi prime of 1, so phi prime of 1 is going to be equal to what? Is going to be equal to just 1/2 pi. That's great. So that's going to be a pi over 2. Okay. If I do the next derivative of this thing over here, the next derivative of this thing is going to be what? It's going to be phi double prime of t. On one hand, phi double prime of t, let's do the derivative of this formula. Well, now we have to keep that negative sign in there. So it's going to be a positive what? That's going to be a positive, it's going to be a positive 3/4 t to the -5/2 pi. And this would be equal to what? Well, now I'm going to have a factor of 2 in the numerator over here. So that's going to be a 2 integral over r of what? Of dx over t plus x squared quantity cubed, right? And so if I plug in t equals 1 to this formula over here, I say 3/4 pi is equal to 2 times that thing. So 1 times that thing is going to be 3/8, right? So this is going to be -3/8 of pi. So in other words, in this case, it says that phi double prime of 1 is going to be equal to 3/8 pi. Beautiful. Of course, now 1/2 is the same as 4/8, so that's 4 over pi times 4/8 minus 3/8 is pi over 8. So the pi's are going to cancel out over here, and you're just going to have a 1/2. So the information of this parameter theta for the Cauchy distribution is exactly equal to 1/2. Thank you very much.